Okay, let's do a quick walkthrough of my burgeoning plotlib library. So the download link for plotlib.jar is in the document, and you put in your project, and you right-click, and you say Add as Library. Here's my project so far. So I'm reading a sample sensor data file. I'm splitting it. I'm splitting the columns as separate lists. I'm calculating the magnitudes, and then based on the magnitudes, I'm counting how many peaks. So that's all done. I want to show you now how to do the visualization part of it. So you can create a scatter plot called plot, new scatter plot. And the inputs are the upper left-hand corner, the XY coordinates for the upper left-hand corner of the plot, and the lower right-hand coordinates for the plot. We have to create two lists, one list of X coordinates and one list of Y coordinates. Or actually, maybe let's not do that. Let's do it a different way. So there's several different ways that you can plot. Here's one of them. Let's loop through magnitudes, okay? So for I equals 1 to mags dot size, and I'll say plot dot plot, and I'll give it I, which is the index, and that'll be the X value, and then I'll give it mags.getI as the Y value. So I can just say plot like this, but I'm also going to specify some visual properties. So I'm going to say plot.fill color will be red, and style will be dash. And that's not going to show by itself. So there's two lines that you need to actually show it. So you need to construct a plot window, which is a static method in the plot window class called getWindow4. And then you give it the variable that corresponds to the plot that you actually want to make the plot window for, and you give it the size, the width, and the height. Okay, and so then you can say window.show, and that will display it. So let's go ahead and give it a go here. So here's what it looks like. You might be wondering why this isn't red, and it's because I used the wrong property. I shouldn't have used fill color, I should have used stroke color. So we'll fix that in a second. But you can zoom in by clicking and dragging, like this. Just as a quick note, okay, so there we go, we're sort of seeing the pattern. As a quick note, I'm gonna leave this point out when I click and drag, and you'll see what happens. I left the point out, so this point should have connected to a point above, and then down to this point here. So that's a bug in my plotting library. If the point is not in the current viewport, it does not get connected. So I got to fix that. But for the moment, don't try and zoom into the middle here, because that'll leave a bunch of weird disconnected lines. You can right-click to unzoom. Instead, make sure that you're going from the full top to the full bottom in order to see interesting behavior. So let's go ahead and fix a couple things. So instead of fill color, let's say stroke color. And then let's also do stroke weight. So I'm going to set the stroke weight to 2, and let's render it. Let's play it one more time. Okay, so that's looking a little bit better. I think, and again, we can zoom in if we want to. I think it might be nice to make the window wider. So let's try that. I'm going to make the width be 1200, and I'm going to make this be 1100. And let's do it one more time. Okay, so it looked pretty good. I've zoomed in a little bit. Here's what it looked like originally. So you can fiddle around until the display looks the way that you like it. Before I go, let me illustrate how you could plot the individual points that corresponds to where your algorithm thinks steps are being taken. Okay, so I've written a method called getPeakIndices, where I give it my magnitude array, and it will return an array list of all of the index values where peaks occur in the magnitudes list. And then peak values, I give it the list of the indices where the peaks occur, I give it the list of the original values, and this returns just the particular magnitudes that represent peaks as given by this list of peak indices. So in other words, these are the x coordinates where peaks occur. These are the y coordinates where peaks occur. So I can add another plot here. Oh, here, hold on. So yours looks like this right now. Well, if you were following along with me, yours looks like this right now. Let's add a second for loop to the plot. If you add another input to plot other than x and y, you can tell it which subplot you want it to be part of. So you can plot several different things at once. So here I've added a 0 before the xy. And so anything that's plotted with this index 0 is going to be part of the subplot that is rendered as red with dashes. Here if I have 1, it will be rendered as subplot 1, and it will have a stroke color of blue and a stroke weight of 5, and the style will be dot. So it will display differently. And the x coordinate I want is going to be peak indices, get I, and peak values, get I. So those are my xy values. And then instead of mags, we'll do peak indices.size. Great. Now let's look what it looks like. So you can see here a blue dot being rendered at every single peak. And again, we can zoom in if we want to and see what they look like. But this is going to be helpful next week when you want to figure out why is your algorithm overcounting. So I can see here, some of these peaks probably are steps, but some of these lower peaks probably, like these ones in particular down here, almost certainly don't correspond to steps. So this can be your first step in brainstorming improvements.